Put it on the pocket.
Okay, I'll put it on the pocket. So نبدأ ولا المفروض نبدأ ولا المفروض الصوت مش قوي؟ أنا مش عارف. This is for and yeah, this is the one. Yes. Yeah, of course. My name is Amr Faham. I'm a Cloud Foundation and HCI Senior System Engineer. I'm based here in Dubai, covering UAE and North Africa and Levant. So in the session today, I will just go through an overview of our latest technologies, VMware Cloud Foundation, followed by a very high-level overview as well on VMware Vsan. This is our software-defined storage solution. Afterwards, I will hand it over to my colleague, Ala Sultan from Intel. So she will walk us through the different hardware capabilities that Intel can help us to give the right performance and resiliency for our applications. So who we are and what is VMware. So basically what VMware has been doing on the past years is that we wanted to abstract all the functionalities in the software layer. So the need to rely on the hardware is not there anymore. So from the compute perspective, and this is what we've been doing for the past 20 years, like we virtualize the compute requirements. So there is no need to have the physical servers. Afterwards, now we have the software-defined storage. So we virtualize the storage, so there is no need to go with the traditional architecture. So everything is, as you can see, software-defined, and as well in the networking part. So why we are doing this? So why we have all the functionalities abstracted in the software layer? So the main purpose is to have one platform where you can use anywhere. So for example, today you want to do it on a private cloud, or you want to go on AWS, Azure, Google. Maybe you want to deploy your solution on the edges. So the traditional way of IT and how it was before is not there anymore. So everything is abstracted on the software layer. So we give you the choice. What do you want to do? You want to do your private cloud? You want to go public cloud? You want to run a traditional application? You want to go with a cloud native application? So the decision is yours. So if we have a look here, this is the table on the left is the traditional applications, and this is what we have been doing in the market for years, right? This is what I've been doing personally for the past 12 years in my career. But we have been seeing a lot of things coming lately. It's like terms like cloud native applications. We want to have Docker, we want to have Hadoop, we want to have MongoDB. So it ended up like I need to go with a different architecture to support this kind of containers, for example. So what we want to avoid is to have different silos. We want to give the same IT admin who are administrating the traditional architecture to administer as well the cloud native application under the umbrella of our software defined data center, which is the Cloud Foundation. Why we are doing this? We are giving you the capability to have a common infrastructure across all platform, common operations. So as an IT operator, I don't have to learn new things or maybe adapt myself to different technologies, which will end up with different configurations or a different platform. And of course, the last but not least is have a common security standards. So whatever I'm implementing here on-prem, on cloud, I will maintain the same security compliance across different platforms. So what are the components of the VMware Cloud Foundation? So we have the stack. So what is VMware Cloud Foundation? Actually, it's not something new. It's what we call it. It's an engineered solution. So we bundled all our products, the vSphere in the compute part, Vsan and the storage part, NSX and the networking part, and we bundled them as a single bundle. So when the moment you start deploying our products, you don't have to put every stack on its own. You need to just launch the wizard and everything will go automatically. You have like in few hours a full stack up and running, which is the management domain. Why we are doing this? So again, this is the platform. So today, if you want to have it in a customer managed infrastructure cloud, like if you want to join me later after this session in the demo, I can show you. In our demo, we have a VMware Cloud Foundation here in Dubai. We have another instance landing in Paris in France, and the third instance in AWS. So the three sites, they have VMware Cloud Foundation, and I will show you seamlessly how we can move the virtual machine from each side of these to the other side with the zero packet loss. Okay, this is because we don't rely again about where the hardware is and what kind the hardware and what type of hardware vendors, because in order to power this, we have a variety of vendors where you can choose from. So if you want to go with the Dell, HP, Fujitsu, Lenovo, Cisco, whatever, again, VMware and Intel, they are both providing the compatibility across different vendors. So again, what we care is the software layer, and Ola will give a brief afterwards on how the right hardware choice from Intel will help us to boost the performance of your environment. So how does it look like? Why do I need a private cloud? So why people, let me ask it the other way. Why people go to the public cloud experience? Because mainly two things. In the cloud, you don't care about what version is running there, right? You need to have your application. And most important thing is the dynamics itself, right? I need to have a service now. If we do it the traditional way, I need to go to a storage admin, I need to go to a networking admin. It takes a lot of time. So what if we automate all these processes? So the idea is, since everything is a software-defined module, so whenever I have a workload, I can easily integrate it inside my environment. I can easily decommission a project, add another one. So if I have a traditional application, I want to go with the databases of Oracle, SQL, I have Kubernetes, I want to run cloud-native applications, I want to have a BDI environment. Everything is compatible in our platform, so we can have various workloads. And the most important thing is that we give you the cloud-like experience, but on-prem with our platform. The most important thing why we recommend the VMware Cloud Foundation is that since it is an engineered solution, the lifecycle management itself is very important. So you have the option, we can go and put the modules on its own. You can put vSphere, Vsan, NSX, whatever. But the most important thing is to have one interface to manage all the life cycle management of all these components. And this comes with the VMware Cloud Foundation to have SDDC manager controlling all the modules inside our stack. So if I have the VCF, it comes with the SDDC manager where it can manage all the LCM and functionalities of the platform. The most important thing, you as an IT administrator will be able to run all the operations, either traditional or cloud native. So all the developers, there is no need for them to go on the cloud, so you can provide everything on-prem. So what is inside? What is the components of of this stack? So the main components of the stack is vSphere, Vsan, NSX, and vRealize. And I will focus on the next slides will be on the first two parts, because I'm an HCA specialist, and we want to talk how Intel will help us in the hardware to provide the good performance in the Vsan part. So Again, I'm not saying we are under one umbrella, and it's an advantage to have it in under one umbrella because of a single vendor. But the most important thing is that each single module of this, they are ranked as #1 according to IDC and Gartner. So the road to the full SDDC starts with the vSphere vSAN, and you add the different software layers to have the flavor of the full software-defined infrastructure. I don't want to go through marketing slides here, but just worth highlighting. So those are our references everywhere. And today we celebrated a few months ago that we have more than 30,000 customers in running vSAN. The most important thing that you need to consider is that what is the segment of these customers. I can tell you that many customers we have as a reference comes with an enterprise customers, and they trust our product because of mainly two things. First is the resiliency that you get with the product itself, and second thing is the performance. And this is how what I will show you in the coming slides, how we can provide the performance. Yes. Cheapest solution as a vSAN. Third thing, yeah, it is a cheaper solution because we eliminate the need of having a 3-tier architecture. So we just need a compute node and direct attached storage. I will show it in the coming slides. So what is VMware vSAN? So basically, maybe you are familiar with the vSphere architecture. So what we did, the same kernel that we use for the vSphere, we added vSAN inside this kernel. So it is integrated inside our hypervisor, and this is one of the main competitive advantages that we have with the vSAN because of two things. There's no kind of bottlenecks that you will get. So all the virtual machines, they have direct access to the kernel. And the most important thing is that the scaling of the solution itself. We have something called a linear relationship between the performance and the number of nodes. So whenever I add nodes, I will linearly gain performance on my node. So if for example, I have 4 nodes and they have 100,000 IOPS, I can have 8 nodes running 200,000 IOPS. So there is no limit. Of course, with the technology of what we have, I will describe in the architecture how the cache tier and the capacity tier help us to go with this purpose. So I would say sky's the limit, and we will have a single platform that will serve both traditional applications and cloud native applications. So how does it work? So as I mentioned, it's already embedded inside the kernel, and we have 2 tiers inside the server. So there is no need to go with a SAN switch with a storage controller or a storage array. So the same compute node that I will use for the vSphere and host my virtual machines, I will add 2 tiers, the cache tier and the capacity tier, the drives itself, and it will create a virtual pool. This is the software-defined storage that will be visible for all my virtual machines. So I would say that every node acts as a storage controller. So you can imagine having a traditional ones, you have 2, 4, 6 controllers. You will definitely go through a bottleneck, right? Whatever number of this that I will add later on top of these nodes, I will always be blocked or capped by the number of controllers that I have. But since every node acts as a virtual controller, I don't have a limit. So whenever I want to do a scale up or scale out, and I want to add more disk or more nodes, this will help me get more performance. And of course, I will be able to host more application. And last but not least, before handing it over to Ola, is that the question I most of the time I get, what is the best application that I can use with the vSAN? So actually, I know that many people 7-8 years ago, they were afraid to, and there was a kind of resistance to go with such a technology. But today, with the partnerships that we have, the reference that you have, it showed a great trust in the product because of the resiliency of the product itself, how it provides an enterprise-grade availability to our mission-critical applications. And second is the performance that we get. So when we do benchmarking and we go against traditional architecture, and this is something in my demo as well, I can show you that in 4 nodes, we can provide more than 400,000 IOPS in only 4 nodes, like 8 use inside the rack. If you want to do something similar in the traditional architecture, you will pay a lot, and you will never be able to put everything in half a rack. So again, today, we have references, we have proven partnerships and technologies in all kind of different workloads. With this, I will conclude my short presentation. I will hand it over to Ola. She will go through the Intel modules, how they can help us provide a better performance to give the maximum availability to our solution and the best IOPS and performance that we get of the application. Ola, over to you.
Yeah, I don't know how should I put.
But you can talk like that also, no problem. If you want.
Hi, the sound is good. So you hear me well, yeah? Hi, everyone. This is Ola Sultan. I am from Intel, and I am an industry technical specialist. And my main focus is on Optane technology and how we can actually leverage this technology to add value propositions to our solutions. But today, mainly, I will be focusing on the VMware solution and how we can use Intel's wide portfolio to get the best optimization and solution enhancements. So as Amr mentioned earlier, VMware vision is the VMware Cloud Foundation. The idea of having any application on any cloud, any device, whether it's on public cloud, private cloud, or even on the edge. The idea of having your compute, storage, and network based on virtualized environment to provide you the full flexibility. So for example, if you want to copy data from one data center to another, it's simple like copy and paste. If you want to migrate your workloads from your private cloud to the public cloud, it's done seamlessly. And the beauty of this solution is whatever device you're using on any application, you can have one simple management for all your operation. So how actually Intel fits in this solution? Unlike any other company, Intel was able to fit in the 3 pillars, the storage, compute, and network. So if you go to any other company, you can get the compute, for example, but you need to go to another one to have the storage and the network. But Intel's wide portfolio was able to fit the full solution. Before we go more on details about the VCF solution and Intel's portfolio, let's have a quick look about the Optane technology. So what's the Optane? Before the Optane, there was a huge gap in terms of performance and cost. What happened is that Optane filled this gap by having 2 new products, Optane persistent memory and the Optane SSDs. Both of these products are based on a 3D cross-point technology, and they are a bit addressable. You write into place, no garbage collection. So the first product we have is the Optane persistent memory, and it's mainly to expand your memory. So by having the right ratios, and you can have the DRAM and the Optane persistent memory to have the best cost and performance optimization. It supports 2 modes, memory mode and app direct mode. And we will go in a little bit details in the next couple of slides. The other product is the Optane SSDs. And this one is for improving your storage performance. So whether by accelerating, caching, tiering, depending on your solution. So now let's get back to the VCF story. So as we mentioned, we have 3 pillars, the compute, storage, and network. So first, from the computing perspective, we have our 2nd generation Xeon and the 3rd generation Xeon Ice Lake, which is up to 40 cores and has 1.4 times better performance comparing to the previous generation, and has 8 memory channels. And here where the Optane persistent memory comes. So by having the Optane persistent memory, our latest one, PMM 200 series, it's 32K megahertz, and it is 32% higher performance compared to the previous generation. The second pillar we have is the storage. So by having the Optane SSDs, our latest one has very high endurance. It's up to 100 data write per day. And specifically in the VMware solution, we use it as a caching tier. And we will see in the next slides how actually this improved the performance a lot. And the next and the last pillar we have is the network part. And it's the Intel Ethernet 700 and 800 series. It's come with 10, 25, 40, 50, and even 100 gigs, depending on your needs. So using Intel's portfolio, we were able to fit the 3 pillars. How exactly Intel fits in the VCF store? So in any VMware solution, we have 2 parts, the vSphere and the Vsan. The vSphere is for the computing part. And as we mentioned, we have 2 modes for the Optane persistent memory, but today we will be focusing on the memory mode 1. When you use the Optane persistent memory in the memory mode, you actually have the Optane persistent memory acting as DRAM, and the DRAM acts as a caching tier for it. And we will go a little bit depth in the next slides. From the storage perspective, we have our Vsan. And in this case, we put the Optane SSDs as a caching tier. And the reason we are doing this, simply as we mentioned, the Optane SSD has very high endurance, and this exceptional performance and the simultaneous reading and writing, all of this stuff makes perfect sense to have the Optane SSDs in the caching tier to enhance your overall performance. And you can have the normal and NAND SSDs in the capacity tier with the low endurance for the budget perspective. Okay, so we spoke about Intel's portfolio and how it fits in all of this. So how actually we can use it to have solution enhancements. So from the computing part, we mentioned that the Ice Lake is up to 40 cores. So you can actually have higher core CPU, and by having higher core CPU, you will end up supporting more VMs. Higher compute means more memory required. And here where the Optane persistent memory plays a major role. By having the Optane persistent memory, you will end up having lower cost. And we will see the numbers in the next slide. Okay, so we have more compute, more memory. Now, what about the storage part? By having the Optane SSDs in the caching tier, you can have up to 60% performance enhancements. So now we have more compute, more memory, 60% higher performance, and by performance, by the way, I mean higher IOPS and lower latency. By combining all of this together, the node consolidations appear. So instead of having 6 nodes, you can end up having only 4 nodes and actually hosting 100 more VMs. And less nodes means lower cost, more optimizing your hardware, and lower management for sure. Okay, so we did the node consolidation and we end up having 4 nodes. The licensing benefits appear. So by having to be able to license 4 nodes instead of 6 with this 33% less, you will end up actually saving again money. Okay, so we kept saying that the Optane persistent memory saves a lot of money and it's a lower cost solution. And so now let's see numbers. So we have here 2 hosts. One of them is 2 terabytes DRAM only, and the other is a combination of persistent memory and DRAM. The first one, let's zoom in first from the memory perspective. So by having DRAM only, comparing it to the persistent memory and the DRAM, we were saving more than 50% of the memory cost. Okay, so now let's zoom out and see the total solution. By having only the Optane persistent memory, we were able to have 20% performance, 20% cost reduction from the platform level. So if we have 4 hosts DRAM only, you can end up having 5 hosts with the Optane persistent memory, and 1 more host means a lot more VMs. Okay, so how should I know if this Optane persistent memory is a good fit to my environment? After doing a lot of testing on different environments and different workloads, we were able to find that. So in any VMware environment, as you know, the memory is managed in the host level and the host distributed among the VMs. And it's divided into 3 stages: active, idle, and free. So the active is the memory that you are currently using. The idle is the one you used a while ago, but you still cannot be claiming as free. And the free one is basically the one that you are not using. So what we found is that by fitting the DRAM in the active memory and the persistent memory take care of the rest of the memory, you will have the best performance. And here where the cost reduction comes. So instead of using your whole memory for the DRAM, no, just the active part, DRAM will use it as a caching tier, and the rest will be taken care of by the persistent memory. Okay, so how should I know my active memory and the consumed memory and all of this stuff? In VMware, it's pretty simple. Using the vCenter and the vSphere, you're able to track your active memory. And very simple, you can do it manual or using a tool. And in this specific example, we have 406 gigs of consumed memory, and 31 gigs of this consumed memory is active, which means 7% only of the memory is actually active. In this case, the Optane persistent memory can take care of the consumed part, and the active memory can be taken care of by the DRAM. So to sum this up and to make it simple, if your active memory is actually less than 25%, the Optane persistent memory will be a major role for your applications, and you will save a lot of cost. If it's more than that, it will not be the best fit. So here is a use case where a customer was having a VDI solution of 41 hosts, and he did the testing using the vSphere and the vSender, and he found that he has 10 gigs of consumed memory, and one of this is active. So it's less than 25%, so Optane persistent memory will work for him. And after adding the Optane persistent memory, he ended up having 15% less expensive cost in his total 41 host configuration. So to sum this up, Intel and VMware has been collaborating together for more than 15 years to provide the best optimization for your workloads and to be part of your journey. So by adding the Optane technology on the VCF solution, you will have the scalability and the larger VM density, where you will be able to host more VMs on less number of nodes. And from the scalability and reliability perspective, by adding the Optane SSDs, you will have higher IOPS. And from the memory perspective, you will be able to host more with less cost. And at the end of the day, you will have what we all need is the optimized IT budget. Thank you so much for your time. Thank you for listening. And I will be happy to answer any question later on. Thank you. Thank you.